This is a National 4, National 5 chemistry lesson on the topic of bonding, and today's lesson specifically is going to look at ionic bonding. So the aim of today's lesson is to be able to identify and describe ionic bonding. Our success criteria for today are to state the definition of ionic bonding, to identify the types of elements that can make ionic bonds, and to identify the properties of ionic bonding and how they are formed. So ionic bonding. Now, we always need to remember whenever we're talking about bonding is that atoms bond to become stable. And that means they bond to end up with the same electron arrangement as a noble gas. Metals and non-metals can bond by donating and accepting electrons. This is different from covalent bonds where electrons are shared. This is whenever we have a metal bonding to a non-metal, electrons are given away or they are received. The metal gives away electrons and the non-metal accepts those electrons. When an atom gains or loses an electron, it becomes an ion. And an ion is a charged atom. So for example, we have sodium there. Sodium is a metal. Sodium will always give away electrons. Sodium has the electron arrangement 281. It wants to become stable and have a full outer shell. Its options, if it's got one electron in its outer shell, would be to gain 7 electrons or lose 1 electron so that its next lowest shell becomes its outer shell. Atoms are lazy and atoms always do the thing that's easiest. It's easier to give up 1 electron than it is to try and find 7 electrons, so sodium donates or loses an electron and becomes a sodium ion. Because it has lost an electron, it becomes positively charged. It's lost 1 electron, so it has a 1 positive charge. So as I said, metals always lose their outermost electrons to form positively charged particles. So metals always lose their outermost electrons. Doesn't matter how many they have, they lose them. And remember that when you lose an electron, you're giving away a negative charge. And that means that you're left with more positive charges from the protons in the nucleus, which gives the atom an overall positive charge. In ionic bonding, non-metals always gain electrons to form negatively charged particles. If they are gaining electrons, that means they end up with more electrons than protons and they will become negatively charged. So chlorine, we have chlorine represented there. It's got 7 electrons in its outer shell. It is 287. When it forms a chloride ion, well, it could give away 7 or it could take 1. It's easier for it to take 1 than give away 7, so it does that. And it ends up with 8 electrons in its outer shell. Because it has gained 1 electron, it becomes 1 negative and an ion. Now, this is really important. We need to know the definition of an ionic bond. So I would spend some time on this slide making sure that you remember this exact statement. So an ionic bond is the electrostatic force of attraction between oppositely charged ions. An ionic bond is the electrostatic force of attraction between oppositely charged ions. So how does ionic bonding work? Well, when a metal and a non-metal react with one another, the metal wants to give away electrons and the non-metal wants to receive electrons. So what happens is that the metal donates electrons to the non-metal and the non-metal accepts electrons from the metal. Now, the electrons are not shared, they are transferred. So an electron moves from a metal to a non-metal. There's no overlap of the electron shells. The two atoms are completely separate, but the electron essentially has jumped from the metal to the non-metal. And once we have our ions, negative and positive things attract one another, and because we've got these negative and positive things, they get stuck next to one another. And that's what an ionic compound is. So the ions in sodium chloride. So sodium chloride is salt. And what's happened is that the electrons from the sodium have moved and transferred over to the chlorine. That has produced positive sodium ions and negative chloride ions. Now that we have ions, we can form an ionic bond. So now that we have ions, we can form an ionic bond, and that ionic bond is just the fact that positive and negative things stick to one another. And they stick together in an alternating order, so it goes positive, negative, in something we call an ionic lattice. And they attract to each other very strongly. Now, in that diagram, each sodium ion is attracted to every chloride ion in the picture, not just one, all of them. And every chloride ion is attracted to every sodium ion, not just one. That's really important to remember. In an ionic bonding, all of the sodium ions are attracted to all of the chloride ions, and all of the chloride ions are attracted to all of the sodium ions. And they form a lattice, it means a regular pattern. Now, just like covalent lattices, because there are lots and lots and lots of bonds and lots of attractions, it needs a lot of energy to break apart an ionic compound, which means that ionic compounds have high melting and boiling points. This is another representation of sodium chloride, and you can see it is really, really, really large. And the ionic bonds are the force of attraction between oppositely charged ions. And in that picture on the right, as I said before, every negative ion is attracted to every positive ion, and every positive ion is attracted to every negative ion. There are hundreds and thousands of ionic bonds within a covalent structure. And ionic bonds, because it's a regular repeating pattern, we call it a lattice. So, state the definition of ionic bonding. Ionic bonding is the electrostatic force of attraction between oppositely charged ions. Identify the types of molecules that can make ionic bonds. Well, any compound that is made from a metal and a non-metal will produce ionic bonds. So you look at the name of the compound. If there's an element that's a metal and an element that is a non-metal, it will have ionic bonds. And identify the properties of ionic bonds and how they are formed. Well, the properties of ionic bonds are that they form a lattice, they have a very large structure, and as a consequence, have very high melting and boiling points. So now we've got some revision questions. So how ions are formed? What is it that has to happen for an ion to form? Well, the answer for this is ions are formed when a metal atom loses an electron and becomes positively charged. Or you could have said when a non-metal atom gains an electron and becomes negatively charged. Remember, metals lose electrons, become positively charged. Non-metals gain electrons, become negatively charged. How could you test a substance to determine if it is ionic? How could you test? Okay, next question. Describe how you could test a substance to determine if it is ionic. Well, you might have said it'll have a high melting point, and that is correct, but covalent networks also have a high melting point, so there has to be something else. Now, this is not a point that we got into in the main lesson, but it's really important for being able to detect ionic compounds. Ionic compounds, whenever they are solid, cannot conduct electricity. Whenever you melt or dissolve an ionic compound, it will conduct electricity. So a test to determine if a compound is ionic is 1, it will have a high melting point, and 2, it will conduct electricity as a solution, but not as a solid. So it's really important. Ionic compounds conduct electricity whenever they are liquids or dissolved, but they cannot conduct electricity when they are solid. And they also have high melting points. What type of elements take part in ionic bonding? So what type of elements take part in ionic bonding? Well, this one is you need a metal and a non-metal. If you have two metals, it's not going to be ionic bonding. If you have two non-metals, it's going to be covalent bonding. So only when you have a metal and a non-metal do you have ionic bonding. So this one's asking for the definition of ionic bonding. And the definition of ionic bonding is the electrostatic force of attraction between oppositely charged ions. So we're looking for the missing word. Ionic compounds exist as a giant something of oppositely charged ions. The word is lattice. And our final question, which of the following pairs of elements would combine to form an ionic compound? So you might want to, use your periodic table to look at what types of elements all of these ones are. The answer is A, lead and fluorine. That is because lead is a metal and fluorine is a non-metal, and those are the types that you need in order to form an ionic bond. Sulfur and oxygen are both non-metals, so they will form a covalent bond. Carbon and nitrogen are both non-metals, so they will form a covalent bond. And phosphorus and chlorine are also non-metals, so they would form a covalent bond. So that has been our introduction to ionic bonding. Next time we will look at another type of bonding, so I'll catch you then.